This video is about the basics of designing a graphical user interface. The simplest way you can get graphical windows to appear on the screen is using a class called JOptionPane. It's located in a package called javax.swing. So if you import that package into your program, you can use this class and some of the other graphical classes in Java. And the JOptionPane class has several static methods that you can call to pop up various kinds of information windows called dialog boxes. And the simplest one is the one called showMessageDialog, which just pops up a message on the screen. This method takes two parameters. The first parameter is a parent window, and if you don't have any such other window, you can just pass null here to not attach this message pane to any other parent window. And the second parameter is a message, generally a string, that you want to display on the screen. There's a couple other kind of message boxes. You can pop up a confirm box that sort of asks a yes, no, or cancel message. You can also pop up an input box that will prompt for the user to type in a value. Let's do a quick demonstration of the show message dialog. If we go to our editor here, if we import the javax.swing.star here, then down in the main method we can write JOptionPane.showMessageDialog hello world. So this would be a graphical equivalent of the classic hello world program. Oh, excuse me, this method takes two parameters. I have to pass that parent window. I'm going to pass null for that. There's not any parent window on the screen. So let's run this now. And when the program runs, we see this message box pop up that says hello world. So this is like the very simplest graphical program that you could write. But this isn't really how you do graphical programming in Java. Normally you want to specify an entire window that you're going to create with different elements inside that window. So if you want to do that, I have to teach you about something called frames and something called components. So a frame is a window. This entire graphic that you see here on the screen is called a frame in Java. And if you create a frame, you can add different things inside the frame. Like this particular frame has a text box where the user can type input, has a button that the user can click with the mouse cursor, has some labels here of text explaining what the different temperatures are going to be that this particular program is going to produce. So those on-screen widgets are called components. And components also have to be positioned in the screen, in the window, and the way that Java does that is using something called containers and another option called layout managers that we'll talk about in a different video. So we need to learn about these frames and some of these components in order to write more sophisticated graphical programs. Here are some of the things that you can do with a frame. In Java, a window frame is implemented as an object of a class named JFrame. And when you construct a JFrame, there's a lot of different properties you can set on that frame, including the icon to show in the window and the title message text to display in the window and various other things. So there's also a set of properties that apply to every component, not just frames. These are listed in the Building Java Programs textbook as well. Here are some of those properties that all components have. They all have background colors and foreground colors, and they have fonts. You can enable and disable them. You can change their size. You can change whether they're visible. So let me show a quick program that pops up a JFrame on the screen. If I go back to this file and I comment out my option pane, instead, what I'll say is I want a JFrame named frame that will be equal to a new JFrame. And now I can set various properties of the frame. For example, I can say frame set title to be my first frame, and frame set size to be 300 by 200 pixels. And if you want to show the frame on the screen, you can tell the frame to set itself to be visible, true. So if I compile and run this program, I should see a window pop up, my first frame. There it is, 300 wide by 200 tall, and there's that title in the title bar, my first frame. And when I close the window, there's a subtle thing here that's a little bit annoying about frames in Java. It actually is still running the program. Just because I close the frame, the program doesn't stop running. I have to tell my editor to abort it manually. There is one more line you should add whenever you pop up a frame that represents your entire program, and that is you should set the default close operation on the frame. This is a bit of a strange line of code, but we talk about it a little bit more in the textbook. We have to say we want the frame to set its default close operation to the constant called jframe.exit on close. And that's a very strange line of code, but what that accomplishes is it makes it so that when I pop this up and then close it, the program will terminate itself rather than just being stuck. And that's pretty important so that the Java virtual machine shuts down. It doesn't waste memory or something like that. So anyway, that's a quick frame on the screen. Now, if we want to add things to the frame, if we want to put some buttons inside it or something like that, we have to talk about some of these component classes and how they work. There is an inheritance hierarchy for all the graphical components. There's kind of a superclass for them all named JComponent, and underneath that are a bunch of subclasses for things like buttons and labels and menus and such, and their names all start with J, so it's easy to identify them. If you want to use them, there's a couple more packages we should use here. We should import a package named java.awt.star. We've already imported javax.swing.star. The reason the swing one starts with X is because it started out as an experimental extension to Java several years ago. So if we want to pop up some of these components, let me show you a few of them and how they work. So the three that we'll play with today are buttons. This is a J button here. This is a J label here. And a J text field are these text boxes right here. And you can construct these by passing in the string of the text you want them to show, or in the case of the text field, you can pass the number of letters wide, the number of columns wide you want the text field to be. So for example, if I want to make a button in my program here, I can create a button right here. I can say JButton is a new JButton. And I can tell the button to set his text to be click me. And if I want to see the button in the window, we say that the frame acts as a container, so it holds the other components. And if you want the frame to hold the button, to store the button inside of itself, you can say something like frame.add button. And think of it like a collection, like a list that we might have learned about in one of the previous chapters. You can add this button inside the frame, and now the frame will draw that button. And so usually we do all these things before we put the frame on the screen. So we set the frame to be visible last. So if I compile that and run it, I see a frame that says click me, and a very strange thing has happened. This button is actually occupying the entire space of the frame here, and the reason that is happening is because we have not specified the size and the positioning that we want this button to have, and so the default is that Java just gives it the entire frame area to use, and so that looks a little bit ridiculous. We don't really want the button to be quite that big. Maybe a more practical example would be to look at the previous slide where we were talking about a Celsius to Fahrenheit converter. So let's talk about how we would get a frame that looked like that. This thing in the top left is a JText field. So we could come back here and create a JText field in our program. Let's say JText field text is a new JText field. I don't know exactly how many letters wide it is. Let's just say 12. And we've got this button that says convert. So let's change our button text to say convert to match that. So let's write convert here. Okay. Now over here we have these two J labels, one that says Celsius and one that says Fahrenheit. So we could make some J labels for those. We could say J label, C label. It's a new J label, and you can pass Celsius here. And we could make another one, Fahrenheit label. So now we've got these four controls that we've created, these four components. If we want to add all of them to the frame, we can do something like frame.add. We've got the text field, we've got the Celsius label, we've got the button, and we've got the Fahrenheit label. Now, if I add all four of those things to the window and then pop the window up on the screen, it looks really funny. I only see the last thing that I added, the Fahrenheit label. That's because Java is giving all four of them the entire frame of space to work with. And so we haven't told the frame how to position these things in a more sensible way. And to really learn how that's done, we're going to have to do a later video about layout management. And so we're not going to be able to cover that fully in this video, but the really quick answer is you have to tell the frame what kind of layout strategy you want it to use to position all of these things. So just as a quick shortcut here, I'm going to tell the frame that I want its layout to be, I think if I look at this drawing here of this window, there's sort of 4 things arranged in a 2x2 grid, you might say. So let's say a new grid layout 2x2. And again, these layouts are going to be covered in another video. So I'm not going to fully spend a lot of time on them. In order to use these layouts, I think in another slide it said I was supposed to import a package called Java awt.star. And by importing that package, I should be able to set these layouts the way that I want to. Let me try one more time. And now we see a window that we can see all 4 of these components here. It still looks a little bit bloated. It looks like it's not quite the right size. So I might have to play with the size a little bit to get it to look the way that I want it to look. Maybe the size should be more like 100 by 200 or something to that effect. So that looks a little bit better. This looks a lot more like the picture on the slide that we were looking at a moment ago. So now we have a window that shows several pieces of information on it, but it doesn't actually do anything when I click this convert button. If I type 34 and I click convert, it doesn't convert Celsius to Fahrenheit. If I want to make the components actually have behavior, I have to learn about one more thing, which is called event-driven programming. So event-driven programming is the idea that you could click on one of these controls or interact with them, and that would cause something called an event to occur, and that would be something that our code could respond to. We could say, when this button gets clicked, I want to handle it in the following way. And so this idea is called event-driven programming. If we want to respond to events on these graphical components, we have to import another package called java.awt.event.star. So back in our program up here at the top, we're going to say import java.awt.event.star. Now, the next thing I need to talk about is something called action listeners and action events. If you want to listen to clicks on a button, there is a method you can call on the button named add-action-listener. You can attach an object to the button, and that button is going to listen to clicks on the button. When the button gets clicked on, the action listener will be contacted using a method named actionPerformed. So let me do a quick demonstration of that. What we'll do is we'll make another class called myListener, and we'll say that it implements the action listener interface. And this is covered in more detail in the textbook. If you write an action listener, this is an object that's going to respond to button clicks. And if you're going to implement an action listener, you have to write a method named actionPerformed that takes an action event parameter. You also have to import the Java AWT event star here. And just for the moment, let's just make it so that when you click on a button, it will pop up one of those JOption panes. JOption pane, show message dialog null. You clicked the button. So to do the JOption pane, we'll need to import javax.swing.star. So I'll save this as myListener.java in the same folder. And now this myListener object is going to be able to respond to button clicks by popping up this message. That's what this file is saying here. So if I go back to this GUI here, this mygui.java file, if this button is the button that I want to respond to the clicks, I can say something like myListener equals new myListener, and I can say I can say button dot add action listener, and I can pass that listener as a parameter. And if I compile that and run it, then what I'll see is when I click this button, it'll say you clicked the button. So every time I click that button, it's going to call that actionPerformed method. If I actually want the temperature to convert Celsius to Fahrenheit, then what I need to do is I need my action listener to be able to talk to this this J text field here and respond by saying what its equivalent temperature would be in Fahrenheit. So if I want to do that, this myListener object needs to know about the text field. So maybe I should pass this text field as a parameter here. when I construct this thing. An easier way to do this, the way that we generally do it when we actually write a graphical user interface, is we kind of restructure this code a little bit. We basically turn this GUI into an object. So what we do is we'll make this an object that has a constructor that does a lot of this work to initialize these components, but we'll store the components as fields inside the object. So we'll make the JFrame a field. We'll make the text field into a field in the object, private JText field text, private JButton button. So we'll make all these into fields. And then when we have this constructor here, we'll just give them all their values. And we don't need fields for these labels unless we talk to them in the code. So we can do that for these as well. We can say private J label, C label, and F label. And then here I'll just initialize their values. Okay, so now the code basically acts inside this object instead of in a static method. In the static method, we'll just say something like my GUI equals new my GUI. So we'll just make a new object of this type here. So that restructuring of the code doesn't change the behavior very much yet, but what it does do is it makes it so that we have references to these things. We have references to these various different controls, components. And here's how that can be useful. We can actually take this idea about the action listener and we can move this code back into our myGUI class. So if I cut this out and I go back to here and I say implements action listener, then down here after this constructor I can just add that action performed method here. And now rather than just saying you clicked the button, I actually am going to be able to refer to all these fields if I want to talk to them. So what we really wanted to do in this program was we really wanted to look at the temperature that was stored in this window here, stored in this text field, and turn that into a Fahrenheit temperature and put it down there. So here's what we can do. In the action listener code here, we can say, well, the temperature in Celsius is the text field get text. This text here is the name of this field up at the top of the code here. I can just talk to that variable now and ask it to get his text. And just to see that things are working, let's just say show message dialog. Like that. One change we can make is instead of putting null for this, we can actually pass the frame as the parent of this window, so it'll sort of center itself with respect to that frame. Now we're getting trouble because of this myListener file that doesn't fully work anymore. I think what we want to do is go back to the code here, and instead of adding a new myListener as the listener to this button, we should tell the GUI to have itself listen to its own button. Now if I run this thing and I click, I type 34 here and I click convert, it pops up 34. So the action listener code is able to grab this value here of 34. So if we go down here, and instead of popping up the temperature in Celsius, we're supposed to convert it to Fahrenheit. So here's what we ought to do. Let's turn this into an integer. The way you convert a string to an integer is you say integer.parse int the text. So let's say int temp c, or maybe this could be a real number. So we might want to say something like double temp c equals double.parse double. So now to convert it to Fahrenheit, I think the temperature in Fahrenheit is 9 over 5 times that plus 32, I think is the formula. And now that we have the temperature in Fahrenheit, we can just put that onto the screen here. This label here is called F label. So we can say like F label dot set text plus temp F. So we're getting the text from this guy, converting it to Fahrenheit, and then setting the text over here. So let's recompile that one more time and run it again. Let's type in 34 degrees Celsius is a sunny 93.2 degrees Fahrenheit. And 100 degrees Celsius is 212 Fahrenheit. Looks like our program is working. So those are the basics of how to get a graphical user interface running. There's a lot of new code, a lot of new objects to talk to. It can be difficult to remember it all, but it's important to understand that you aren't necessarily expected to memorize every single one of these strange method names and constant names and parameter orders and so forth. As you start using a large API of classes like the graphical classes in Java, you would become more reliant on references and reading and tables of class names and method names, and you might even use an editor program that helps you remember these names or helps you automatically complete the names and things like this. So I would not worry about being overwhelmed by all of this at first. You mainly need to understand the concepts and have some examples to follow to look at, and then the details are things that you'll be able to look up. In the later videos in this chapter, we're going to cover how to do a better job of layout here and also how to do more complicated events using more different components in a window.